Hello, I'm Anna Mackay and today we're looking at parallelism and unit vectors. Firstly, parallelism. So we have vector A there and a partner to it, 2A, and another one, -1/3 of A. So having a look, they're all parallel, as you can see there. Even if they're going in the opposite direction, that can still be parallel. So defining that remember those two symbols like that, those equal signs vertically means parallel, is that a scalar multiple of A is parallel to A, of vector A, provided that k is not 0, so that scalar isn't 0, and that the vector itself is not the 0 vector, because that's going nowhere, nothing, so you couldn't really have anything parallel to that. So writing out more of a formal definition here, if you have one vector A and another vector B, we can say they are parallel to each other, as is written here. And also, that's equivalent to the fact that A is equal to a scalar's worth of B, if you like. So B is a multiple of A, and we just have to work out what that factor of K could be. As you can see up the top here, the scalar factor there was 2. In the second one, it was -1/3, and that's how they're connected. Providing again that it's for non-zero vectors. Noting here that the magnitude of A, so its length, is equal to the magnitude of B multiplied by that scalar K, the modulus of that. So back up at the top one here where we had -1/3, the K value there would be +1/3. In this example, we're asked to find S, given that A is the vector 2, -1, and B is S, -2. So what do you know about these? Well, the first fact you've been told is that A is parallel to B. And we know from our definition that if they are parallel, that there is a factor of K here, the scalar of K, multiplied by B. How can that be of use to us? Let's write out vector A. Now we write it horizontally and with square brackets. And we're going to put that equal to K's worth of vector B. Now that is an S there, not a 5. Just be careful how you write those. How's that going to help us? We've got two unknowns here. We've got a K and an S. So how are we going to work that out for two unknowns? We're going to equate components here. So the horizontal component of each vector is in the first position, 2, and this S. But remember, it's K lots of S. So let's write out a statement for that. We've got 2 is equal to KS. And then the vertical component is -1 is equal to K lots of 2. -1 is equal to 2K. Again, you could put K2 or 2K, it doesn't matter which way around. Well, now this second one, that's going to help us solve for K. So solving for that, K is equal to -1/2. We can now use that back up in that equation and remove one of the unknowns. So I'm going to rewrite that out, substituting in for K, which is -1/2 times by S. Tidying that up, -S over 2 is equal to 2, so S, not 5, must be equal to -4. Go back and read the question. It asks us to find S, and we've done that. Unit vectors now, this part of the video. What is a unit vector again? The word unit relates to the fact when something is 1. So that means the magnitude of the vector is 1, its length. Now let's say we've got vector V here and it has a magnitude of 2. Well, what would its unit vector be? What would you have to multiply this V by to turn it into the unit vector? Just some notation points here. We need to have a modulus of 1 to be the unit vector. Now, and the notation for this, the unit vector going in the same direction as the original, is a hat. We actually say V hat. It's an accent and it's called the circumflex accent. But we often just refer to it as V hat. Got the answer there for you. Essentially, you might say to yourself, what would I have to multiply V by so that the magnitude is just 1? In your mind, you might be dividing by 2. 2 divided by 2 gives you 1. But in vector land, we can't divide vectors. We have to multiply them. So the technique is it's 1 divided by the number. That magnitude will give you the unit vector. So that idea there that I've just talked about, 1 divided by the magnitude of the first vector multiplied by the vector itself, because it's a scalar multiple of it, will give you the unit vector, which will have the magnitude of 1. So summarising here, a vector, if you have a vector A of length k in the same direction as v, that is the equivalent of that scalar multiplied by the unit vector. So if we've already gone to the effort of turning into a unit vector, then we can just multiply that by a scalar. We'll do an example in a minute. Or instead of using the unit vector, remembering, well, as in the notation straight away with the unit vector, notice that the unit vector, if you come down here, is written in this notation. And so you can substitute that back into the formula there and use that version if you prefer. And this one here is just tidying that up, putting k as the numerator. Also, a vector A of length k parallel to v, vector v, could be this. So being parallel actually means you can go the opposite direction, which means you'd have a negative scalar version of that, hence the plus or minus sign. And rewriting that in the form of just vector v as opposed to the unit vector. All right, let's put this into practice. So we have A with the components 3i take 1j, and we're asked to find a unit vector in the direction of A. So you see the words unit vector, and you say to yourself, okay, I need to work out magnitude of A. So using what's essentially the distance formula, you take the components, square them, there's a plus in between, and the square root of all that gives us 9 plus 1 is equal to root 10. I actually think I have some slides here I could have added on here. Yes, just remembering that unit vector is in this form here. So we need to first of all work out the magnitude, and we did it, that was root 10. And then our vector v is 1 on root 10, the modulus of that, but it's already positive, and we multiply that by the vector, expanding the brackets to tidy that up. And there is our unit vector v hat in the direction of A. We have a vector of length 4 units in the direction of A, and the facts that we know about this are that a vector A of length k in the same direction of V is the equivalent of this equation here. So vector A is equal to a scalar multiplied by the unit vector. So that's one form that you can do it in. I find it's easiest to do that here because we've already worked out the unit vector. So let's use the information that we've already used. So we're working out a vector A, and that is equal to some scalar multiplied by the unit vector. So since we've already calculated that, let's use that knowledge. We've got k, which is 4 in this case, because we've asked of length 4, multiplied by the unit vector, which we worked out before, and expanding brackets to simplify that. And that's our answer to part B. Part C, if we're asked to find a vector of length 4 units, all vectors, plural here, which are parallel to A. And the facts that we've learnt before are that that's in the same form as we did in part B. So it's the scalar multiplied by the unit vector. Notice how that's the same. But because they can be parallel, as opposed to being in the same direction as A, we can take the plus or the minus version of that. And so the two answers that we'll have, one of them we had from part B. Notice that the first one there was our answer from part B, but because we can also have the negative versions of that, because that would mean they run in the opposite direction, we take the signs of each of them and change it, the signs of each component, and there are our two answers for vectors of length 4 units parallel to A. Join me in the next video, collinear points and ratio of division. Subscribe to the channel if you haven't already. Thank you.